All right, welcome to The Explainer. Today, we are unpacking the biggest story coming out of EMNLP 2025. That's the world's top conference for language AI. And let me tell you, what we saw there, it signals a massive shift for the entire field.
And to understand why this shift is happening now, you have to look at this number, 30. This was the 30th anniversary of the conference. And that's not just a birthday, right? It's a milestone. It signals that the field has finally truly grown up. It's moved way beyond just a niche academic thing and into a global force that is shaping everything.
And you could feel this sense of maturity in the keynotes. Heng Jiak got up on stage and basically threw down a gauntlet with this one line, "No more processing." That really set the tone for the whole event. It was a direct challenge to everyone in the room.
So what does she mean by that? Well, the message was loud and clear. The mission has changed. The whole game of just building bigger and bigger models, that's over. The new frontier, the thing everyone's racing towards now, is making AI that is applied, that is controlled, and that is specialized for actual real-world jobs. So, okay, let's unpack what that really looks like.
First up, systems that act and learn. This new mission, it kicks off by fundamentally changing how we even think about what a language model is. We're moving past the idea of them being, just fancy text generators. The goal now is to build dynamic systems that can actually do things, systems that can act and learn out in the real world.
And you can really see that shift right here. The old way, you had a static model. You'd ask it a question, it would give you one answer. End of story. The new paradigm is all about dynamic, goal-driven systems. Think less passive answer machine and more active collaborator. We're talking about agents that can reason and work together to solve complex problems.
So how does that work in the real world? Well, take something really complex, like providing emotional support or even grading a nuanced college essay. A single AI just isn't going to cut it. So what researchers are doing with frameworks like multi-agent SEC is pretty cool. They're breaking the big job down into smaller pieces, assigning those pieces to specialized AI agents, like an analyzer, a strategist, a writer, and then having them all work together. It's basically building an AI team.
But here's the catch. As you start letting these AI teams operate on their own in the wild, you run into a massive problem. What happens when they make a mistake? If an autonomous agent screws up, how does it fix it? This right here, this is the single biggest thing holding back widespread deployment.
So, one part of the solution is to make these agents way smarter and, more importantly, more grounded in facts. And to do that, everyone is doubling down on a technique you've probably heard of by now, retrieval augmented generation, or RAG. It's basically a way to give a model a live connection to the internet or a private database so its answers are always up to date and accurate.
But here's where it gets really interesting. We're now seeing the next evolution, KGRAG. The big leap is connecting these RAG systems to what are called knowledge graphs. So instead of the AI just grabbing random chunks of text, it's plugging into a structured map of concepts and relationships. It's like giving the agent a real, organized brain it can use to reason, not just, spit back facts.
Which, of course, brings us to the next domino to fall, the quest for trust. If we're gonna have these powerful systems acting on their own in the world, we absolutely have to be able to trust what's going on inside their heads.
And that leads to this fundamental question, the one that's driving a ton of new research. Is the model actually reasoning step by step? Or is it just faking it? Is it just remembering a similar answer it saw during training and just, pattern matching its way to a plausible sounding response? This is a big deal. We are moving way past just tinkering with prompts. We're entering a whole new field you could call reasoning forensics. It's exactly what it sounds like. Researchers are now building tools like this STIM framework that act like a detective, auditing the model's entire thought process to make sure every single step it takes is logical and grounded in facts.
And this obsession with trust has exploded into this whole new landscape of AI control. It's not just one problem anymore. Just look at this. You've got researchers working on making alignment more stable. You have others building sophisticated red teaming tools like Craft, which don't just check for toxicity, they check for complex violations of a company's policies. Then you have things like Culture Steer, trying to make models less Anglo-centric. And maybe most sci-fi of all, you have projects like NMAM, which are figuring out how to do surgery on a model's brain, to go in and surgically remove a piece of information without breaking everything else.
Okay, so we've got agents that can act, and we're building ways to trust them. The next giant hurdle? Making them practical and getting them to work for everyone, everywhere.
And that brings us to the next big theme, practical global intelligence. This really boils down to two huge challenges, efficiency and scale.
Now on the efficiency front, the buzzword is sparsity, but it's kind of split into two different camps, and it's important to know the difference. On one side, you have mixture of experts, or MOE. Think of this as a tool for the people building the models. It's all about making the engine run faster and more efficiently. On the other side, you have sparse autoencoders, or SAEs. This is for the people trying to control the models. This is about popping the hood, finding the engine's gears, and figuring out how to steer it. Two different goals, both using sparsity.
And to be truly global, AI has to break out of its English-centric bubble. So we're seeing this amazing explosion of new data sets for languages all over the world, like Thai and Indonesian. But global also means moving beyond just text. The real frontier is giving AI more senses. We're seeing new models like Raven that can understand the world not just through audio and video, but through things like motion sensor data. It's about perceiving the physical world.
And this brings us full circle. It ties everything we've talked about together. Why are we doing all this? The agents, the trust, the efficiency. What's the driving force? It's one thing, specialization. The massive push to get AI working in specialized, high-stakes industries where mistakes are not an option. And these are the new battlegrounds. Forget about general-purpose chatbots. We are talking about a flood of models and tests built for specific, demanding fields: finance, law, medicine. They're even building models to tackle problems from the International Math Olympiad. This is a whole different level of AI.
But this creates a fascinating new problem, right? How do you even test an AI that's smart enough to be a lawyer or a doctor? Our old tests, our old benchmarks, they're just too easy now. The models ace them without breaking a sweat. So researchers have had to get creative. They're now using other powerful AIs to be the judge.
And I think you can see where this is headed. What happens when your judge is biased? It's a huge issue. We're seeing study after study showing that when you use one AI to judge another, it often has a self-preference bias. Basically, it likes answers that sound like something it would have said. It favors models from its own family.
So now, the field is in this kind of crazy recursive loop. The solution? A whole new field of evaluator alignment. We're literally building tools to align the AI aligners. You have systems like InstaJudge, whose entire job is to de-bias the AI judges that are judging the other AIs. It's wild. So when you step back, the big story from EMNLP 2025 is really this powerful chain reaction. The demand for specialized AI is forcing a revolution in how we build it with agents. That forces a revolution in how we control it with reasoning forensics. And that forces a revolution in how we test it with evaluator alignment. It all connects, and it means one thing. The age of pre-training is over.
This conference really felt like the closing of one chapter and the definitive start of a new one. The age of applied, controlled, and specialized intelligence has decisively begun. It's not coming anymore, it's here. Which leaves all of us with one final thought. Are we actually ready for it?